Hello, this is Dr. Mateki. We're going to look at homework number 5, question 4, solutions. Before we do that, though, I want to have a little bit of a general discussion on using the demand curve to measure the benefits that accrue to consumers from trading in a market. One common way that we can measure benefits is by looking at something called willingness to pay. A consumer's willingness to pay is the maximum they're willing to pay for something, and that gives us a pretty good idea of how much that person values that good or service. The willingness to pay for the nth unit of consumption is given by the height of the demand curve at quantity equals n. Q equals n, as I've written up here. So for instance, let's look at an example. Let's suppose that Q is equal to 3. So you see over here we have a graphical depiction of a demand curve. We're showing the relationship between price and quantity. The demand curve is downward sloping. So let's go ahead and plot 3 here. So we could throw a 1 and a 2 on there as well. So at Q equals 3, the way we can identify willingness to pay for the third unit of consumption is by looking at the height of the demand curve at Q is equal to 3. So we start at 3, we go directly up to the demand curve, take a left turn, and go over to the y-axis. And let's suppose that the price turns out to be $10 when the quantity is equal to 3. We would say that the consumer's willingness to pay for the third unit is $10. Another way to say this is that the consumer values the consumption of the third unit at $10. Another way to describe this is the marginal benefit of the third unit of consumption. So consuming a third unit delivers $10 worth of benefit to the consumer. The next point I want to make is that whereas the height of the demand curve at any particular quantity will yield the marginal benefit, we can also calculate the total benefit by looking at the total area under the curve from 0 to whatever quantity we're consuming. So it's like we're adding up all of the individual marginal benefits from consuming the different units. So for instance, if we're consuming 3 units, and again, given this demand curve here, let's plot 1, 2, 3. So here's Q equals 3. So the total benefit that consumers gain by consuming 3 units would be the area that I'm shading here under the demand curve. Right? So now the question becomes, well, how do we calculate this area? Well, we can do that as long as we have an additional number up here on the y-axis. We need to figure out where the demand curve crosses the y-axis. So let's suppose that this turns out to be $15. Okay, so notice that this sort of irregular polygon here can be divided up into a triangle and a rectangle. Okay, so remember, at a quantity of 3, this was equivalent to a price of $10. So now once we have all of these numbers here, we can calculate the area of the little triangle, the area of the rectangle, add it together, and that's going to give us the area under the demand curve from 0 to 3. So remember, the area of the triangle is 1/2 times the base times the height of the triangle. So the height of the triangle goes from 10 to 15 right here. So the height is 5. The base goes from 0 to 3. So 1/2 times 5 times 3 is going to give us 7.5. 15 divided by 2. Now we have to add that to the area of the rectangle. The area of the rectangle is calculated by taking the height of the rectangle multiplied by the length of the rectangle, or width of the rectangle, times the length. In this case, it's 10 units high and 3 wide. So the area of the rectangle is 30. So the total benefit from consuming 3 units in this case is the area of the triangle plus the area of the rectangle, which is equal to $37.5. One final thing I want to mention is how we can measure net benefits from consumption. So let me draw your attention to this area down here now. So the net benefit from consuming 3 units would be called the consumer surplus that is generated from the consumption of 3 units. Consumer surplus is defined as the willingness to pay minus the price. So what, in other words, what the maximum we're willing to pay is how much we value the item, how much we actually pay is the price. So the difference between those two things is the net benefit from consumption. We'd be willing to pay the willingness to pay, but we don't have to pay quite that much. We just pay the actual market price. So there's some surplus benefit there. We can also think of this as the benefit, the willingness to pay, minus the cost, which is our price. So we're looking at the difference between the costs and benefits, which is this idea of net benefits. So for instance, let's suppose that the price is $10. If the price is $10, we can see that if we're looking at just the third unit, we would go up to the demand curve and we would see that the price is $10. And the consumer benefits, the height of the demand curve, is at $10 as well. So the third unit will yield exactly 0 surplus, 0 net benefit. We value it at $10, we pay $10, so there's nothing left over. However, now let's look at what happens if we're consuming the first unit. On the first unit, in order to see how much we benefit from consuming the first unit, we'd go up to the demand curve above 1, and we notice that we get $14 worth of benefit from consuming the first unit. The cost is $10. The difference between those two things would be the consumer surplus. So the consumer surplus on the first unit would be the difference between what we pay, which is $10, and how much we value it at, which is $14. So we would get $4 of consumer surplus on the first unit. Likewise, if we want to figure out the total consumer surplus or the total net benefit from consuming 3 units, when the price is $10, we would have to look at the consumer surplus of not only consuming the first unit, but also the second unit and the third. So what we would do then is look at the area that is below the demand curve and above the price, which is given by by the blue triangle there. Again, the area below the demand curve and above the price. If we want to calculate the area of that triangle, we need to look at using the formula 1/2 times the base times the height. In this case, 1/2 times the height of the triangle, which is 5, times the base, which is 3. So just like in the other page here, the total consumer surplus is equal to $7.50. All right, now we're ready to answer question 4 from homework number 5. So the first part just simply asks us to graph this linear demand curve. I always find the easiest way to graph a demand curve is to find the x and y intercepts. If you have a linear relationship between price and quantity, all you need is 2 points to define the line. So first, what we can do is plug in 0 for P, and when we do that, the resulting QD, given in the equation there, 20 minus 0.1 times 0 is 20 minus 0, so the quantity is equal to 20 when the price is 0. Right? This is what we would call the x-intercept. This is where the demand curve is going to cross the x-axis. We can find the y-intercept by doing a similar thing. We can plug in 0 for QD and then solve for price. When we do that, we find out that the price is equal to 200. This gives us the point where the demand curve hits the y-axis. We call this the y-intercept. Now we can plot these 2 points here. Here's 200, 0, 200, and the other intercept is going to be Q equals 20, price equals 0, so we're over in this direction. Here's Q equals 20. We don't go up at all on the y-axis, price is 0. So now we have our 2 intercepts, and we can simply connect these points to give us our demand curve. So for part B, we are asked to figure out how many times our friend Bob here is going to go to the doctor if he doesn't have any insurance. If he doesn't have any insurance, that means he is going to have to pay for the entire cost of the doctor's appointment himself. Remember, the question stated that the cost of a doctor visit was $75. So if Bob has to pay $75, what we want to do is use the demand curve to figure out what is the quantity demanded at a cost or a price of $75 for Bob. So if we want to think of this situation graphically, what we are trying to do is figure out the quantity that's associated with a price of 75. In order to do that, we can go back up to our equation here, plug in 75 for the price that Bob would have to pay, and then evaluate this expression, solve it for QD. So if we throw 75 into that equation for the demand curve for the price, we get QD is equal to 20 minus 0.1 times 75, which is equal to 20 minus 7.5. We just need to move the decimal point over one spot. 20 minus 7.5 will give us 12.5. So now we can show that the resulting quantity when the price is 75 is 12.5. So what we would say is that Bob is going to go to the doctor 12 and a half times, so 12 times, 13 times, somewhere in that vicinity. Now for part C, what we want to do is figure out what happens when Bob doesn't have to pay for any of this doctor's visit, right? So he gets to go to the doctor free. The insurance pays for everything. So this is equivalent to asking, what's the quantity demanded going to be when the price is equal to 0? It's free for Bob. Okay, so we're using someone else's money to pay for this. Now remember, there's still a cost to these procedures. It's just that Bob isn't paying for them directly. The insurance company is picking it up. Right? So if we plug again in 0 into the demand curve, what we're going to find is that Bob is going to consume right at that x-intercept. QD is going to be equal to 20 minus 0.1 times 0, which is equal to 20 visits to the doctor. Okay? Notice how the presence of insurance changed Bob's behavior. So when he had to face less of the cost himself out of pocket, he is going to consume more doctor's visits. So for part D, what we want to do is explore the resulting moral hazard cost of Bob having this full insurance. So when he's going to the doctor 20 times, that doesn't mean the doctor's visit is actually free to society, right? To society, this is still requiring $75 worth of resources. The doctor still costs $75. It's just being paid by insurance instead of Bob. Right, so what we can do if we want to look at this graphically is I think it might help to extend this horizontal line at $75, right? And so this is our marginal cost of a doctor's visit. Okay? There's going to be a moral hazard cost imposed on society if the cost of Bob's doctor trips exceed the benefits to society. In this case, the benefits to Bob of going to the benefit that Bob receives from going to the doctor. So remember what we've said in previous slides regarding the measurement of benefits. The total benefit that Bob is going to receive from a doctor visit is the area underneath the demand curve. So what we should focus on is the area right in here, right? Those last 7.5 doctor's visits that Bob chooses to get now that he doesn't have to pay for any of them. And we see on those last 7.5 visits, the benefits Bob gets are given by the area of that blue triangle here. However, the cost of those doctor visits is going to be 7.5 times $75 each, right? So the cost of those 7.5 doctor's visits is 7.5 times 75, which is the area of this rectangle here, right? So the red rectangle is the total cost of those last 7.5 doctor's visits. The blue triangle is the benefit that Bob receives. And so we see here there is some cost that exceeds in excess of the benefits, right? In other words, it's costing society more to produce these doctor visits than they are valued by Bob. And that's where the loss to society comes in. We're using resources to produce something that isn't highly valued. Mathematically, we can figure out the value of the dollar moral hazard loss by a few calculations here. So we can say the total cost of production producing those last 7.5 units is equal to 7.5 doctor's visits times $75 each, which yields a total of $562.50. The benefits to Bob, or the benefit to Bob, is going to be the area of that blue triangle there, right here, which is given by the formula 1/2 base times height. In this case, the base of the triangle is 7.5, the height is 75, so the benefit to Bob of consuming those last 7.5 doctor's visits is 1/2 times 7.5 times 75, which is equal to $281.25. We can clearly see then that the costs exceed the benefits. The costs are $562.50 and the benefits are $281.25. This is the loss to society. So we would actually say that the moral hazard loss is equal to $562.50 minus $281.25. In this case, it's just half of the area of that larger rectangle. So the moral hazard loss is also going to be $281.25. Okay. Visually, the moral hazard loss is going to be the area of this red triangle. For the next part, Part E, what we're going to do is look at sort of the in-between case when Bob doesn't pay all of the $75 cost of the doctor visit, but he does pay something. He has some skin in the game. He does pay some of the cost. So when he pays the $50 copay, he's not going to go to the doctor 20 times anymore, but he still will go more than the 12.5 times when he is facing all of the costs. So we would expect there still to be some moral hazard loss, but not quite as much as if the doctor's visits are free to Bob. So to answer part D, after resetting the graph here, what we want to do is find out how many times Bob is going to go to the doctor when he has the $50 copay. So this is equivalent to finding the QD when the price is 50. So what we need to do then is plug 50 back into our demand curve, and we will see that QD with the $50 copay is equal to 20 minus 0.1 times 50, which is going to be equal to 15. Okay, so Bob is going to go to the doctor 15 times with the $50 copay. So now remember the cost, I think I had this in blue last time. So the cost is still this horizontal line here, so this is still our marginal cost of a doctor's visit. Right? So we can see that, again, the costs are going to exceed the benefits on anything beyond Q equals 12.5. So the last 2.5 doctor's visits, we're going to have the same situation we had before. So after we plug 50 into our demand equation, we can see that Bob is going to choose to go to the doctor 15 times, so we plugged 50 in for price. 20 minus 0.1 times 50 is going to give us 15. So the copay of 50 is associated with a QD of 15. After Bob stopped facing all of the cost, when he faced all of the costs, he went 12.5 times. When he only faces $50 of the costs, he's going to go to the doctor an additional 2.5 times. The cost of those additional 2 visits is going to be 2.5 times $75 each, which gives us a total cost of $187.5. So the cost of going to the doctor these last 2 times is going to be equal to this red rectangle right here, 2.5 times 75. The additional benefits, because there is still some benefit of going to the doctor those 2.5 more times. The additional benefit is the area under the demand curve between 12.5 and 15. It's going to be this irregularly shaped polygon now. So what we're going to have to do to figure out the area, the dollar amount of the benefits, is to break this into a triangle and a rectangle. Right? So if we want to think of the triangle as A and the rectangle as B, we want to add area A to area B to find the total additional benefit from those 2.5 doctor's visits. So the area of triangle A is going to be 1/2 base times height, which is 1/2 times 25 times 2.5. Then we will add that to the area of rectangle B, which is length times width, which is 50 times 2.5. Right, so 1/2 times 25 times 2.5 is 31.25 plus 50 times 2.5, which is 125. We add those two things together, 31.25 plus 125, and we get 156.25. So the benefit Bob experiences is $156.25 worth. The cost is $187.5. So the moral hazard loss here is going to be the cost in excess of the benefits. In other words, we're going to look at the difference between the cost of those last 2.5 visits and the benefit. This is going to be equal to 180. I should do that in red. This is going to be 187.5 minus 156.25, which is going to be equal to 31.25. So the dollar value of the moral hazard loss is $31.25. Again, we can visualize that. That's going to be this area right here. The red triangle. For part F, just a few points here on that. So if we want to compare and contrast the situation with the $50 copay and a 20% coinsurance rate, fundamentally the analysis is very similar. So both of those mechanisms, the copay and the coinsurance rate, are both types of cost sharing, trying to get the consumer to confront at least some of the cost of going to the doctor to make him or her consume wisely. Couple of slight differences though. With the 20% copay, we usually model that by changing the position of the demand curve. It actually, the demand curve with the coinsurance sort of rotates out in this direction here. That's how we get the extra consumption. But again, fundamentally, that does not change the outcome. We're going to be consuming beyond the point where the costs and benefits are just equal. So there's still going to be moral hazard with the 20% coinsurance rate. Now 20% coinsurance is less than $50, so we would expect more moral hazard loss with the 20% coinsurance than we have with the $50 copay. And I just realized the last several minutes we were talking about part E, but I have part D written here. So let's change that to E. So just answered F. Now G, is it possible the copay or coinsurance could actually reduce social well-being? Yeah, you can think of a couple scenarios where this would actually be harmful to society. So one case might be if the doctor's visits are preventive care. So even though on a per trip basis the benefits don't justify the cost for the doctor visit, perhaps there are additional benefits that will be reaped by Bob and society down the line because he's taking care of himself now. So if we're not factoring in those benefits in the future, then we might actually think we're consuming too much when we're in reality consuming too little, because the benefits to preventive care are much larger than what we are considering here. It could also be that there's some sort of externality that Bob is passing along to bystanders. So even though the costs and benefits don't work out for Bob, if there's some additional benefits that are accruing to society, so let's say Bob is going to the doctor and getting immunized, so when he goes to work and is in public, he's not spreading disease, and there's some value to this. If we're not counting that value, then once again we could be drastically underestimating the benefit to society that's generated from these doctor's visits.